Good day, and welcome to another episode of my reviewer series on civil engineering topics focusing on engineering mechanics problems. For this episode, a pipe carrying steam at a pressure of 3.5 megapascals has an outer diameter of 450 millimeters and a wall thickness of 10 millimeters. At one end of the pipe, a rubber is placed between a flange and a flat plate that serves as a cap. To secure the cap, bolts with a diameter of 40 millimeters are used. If the allowable stress in each bolt is 80 megapascals and the initial stress is 55 megapascals, we are to determine the following: the number of bolts required and the circumferential stress developed in the pipe. To solve this case, let's run through our present variables muna. So sealed ng flat plate cap natin yung pipe na nagre-release ng 3.5 megapascal pressure steam. And with that, nakafix yung cap sa flange ng pipe using 40mm bolts. Ang gusto natin malaman is kung gaano karami yung bolts na need natin gamitin, given na may capacity lang yung bawat bolt natin na 80 megapascals. Tapos additionally, meron pa itong na-experience na 55 megapascal initial stress due to the possible fact na yung bolts were tightened up, pressing the gasket to avoid steam leakage. So technically speaking, if we are to determine the number of bolts needed, yung i-consider natin na pressure capacity is reduced na dahil taken up na yung 55 megapascal na stress noong initial na paghigpit sa pagkakakabit ng cap. Proceeding with our solution, we are actually observing the effect of the steam on the bolts. So ang gagawin muna natin is alamin muna kung ano yung force na natatransmit ng steam onto the flat plate. Kasi with that, yun na rin yung reaction force na na-experience ng bolts as a whole. Dahil nga yung bolts yung nagfi-fix sa connection ng flat plate sa cylindrical pipe. Now, knowing that force is equal to pressure times area, ang steam pressure natin as given is 3.5 megapascals. And the area of contact ng pressure na nahohold is yung circular area ng flat plate na nagsisil sa steam, which we can solve using 1/4 pi times diameter squared. And take note, ang given diameter natin is outer diameter. So, need pa natin i-minus yung thickness ng cylinder to get yung sa inner area that experienced the internal pressure. With that being considered, ang makukuha nating area is 46,222 pi square millimeters. Solving for the force applied by the steam onto the cap, we will get 500,270 newtons. To determine the number of bolts required, utilize lang natin yung force equilibrium na experience ng flat plate with bolts. Using force equal to stress times area, ang gagamitin natin na stress to analyze the required number of bolts is yung capacity ng bolt, which is 80 megapascals, pero minus the 55 megapascal initial stress. And for the area, given tayo ng diameter ng bolt na 40 millimeters. So gamitin lang natin ulit yung 1/4 pi times diameter squared. Now, pag minultiply natin itong nakuha nating values, ang makukuha lang natin dito is yung force capacity per bolt, which in comparison to the actual force required is just very minimal. Kaya naman, if we are to determine the multiple number of bolts required, multiply lang natin yung variable for number of bolts, which we can denote as n, to the force experienced per bolt, then equate to the actual force required by the equilibrium. Solving for n, we will get an answer of 16.19. Therefore, we actually need a number of 17 bolts to secure the cap onto the pipe. So take note, kaya tayo nagre-round up ng values instead of rounding down is dahil yung nasolve natin is yung minimum na required. And if mas bababa pa dyan yung gagamitin natin, bibigay na yung pipe cap natin. Moving on to the last requirement, yung circumferential stress na tinutukoy natin is yung stress na experienced along sa circumference ng pipe. And to solve this, gamitin lang natin ulit yung force equilibrium and stress formulas na ginamit natin kanina. And para ma-visualize natin kung paano yung force system na magaganap, kuha lang tayo ng portion since wala naman tayong given na length and hatiin natin yung pipe along its diameter. For this, pwede tayo mag-assume ng value. And let's just say na yung length natin is 1 meter for simplicity. With that, ang forces na involved dito is yung applied ng steam na pressure and yung tension na magaganap along the pipe walls. So basically, ang formula natin for force equilibrium would be force F equal to twice of force T since magkabilaan na position ng walls ang considered. Solving for P, gamitin lang natin ulit yung pressure times area in which 3.5 megapascals yung given from the steam. Then yung area naman na gagamitin natin is yung rectangular surface exposed dito sa figure, which is diameter times length lang. So, 430 times yung 1,000 mm na assumed length. As for the force naman ng T, stress times area lang ulit, but in this case, yung stress nga along the circumference yung unknown value. For the area, we are given the thickness na 10 mm times the assumed length na 1,000 mm. So, with our unknown value, plug lang natin tong mga nakuha natin into our force equilibrium equation para makuha natin yung value ng stress P, which will give us 75.25 megapascals. And that's it. For further questions, don't hesitate to ask in the comment section below. And with that, this situation is finally solved.